Here we go. What is a radian? All right. We have two different ways to measure angles, and that's really what trigonometry is all about: triangles and angles. Okay. A radian measure is the intercepted one radian. A radian is when the arc is the same length as the radius. So I'm just going to give you a moment to write this down and draw the picture, and then we'll talk about it. Okay? You've worked with radians before, but like I said, last year and the year before, I suppose, was both. So we measure radians by taking the length of the arc length and dividing it by the length of the radius. So this description right here is describing a radian, 1 radian. If the arc length is equal to our radius, then our radian measure, that angle measure, would be 1. Now a lot of you are thinking, radian measure, you think of the number pi attached to it. Oftentimes, our radian measures will involve pi, but that's not a requirement, okay? Basically, what we're going to do is we're going to take that piece of circumference, that arc length, divide it by the radius, and that's our radian measure. Now, we're not actually having to physically make that measurement, okay? But that is how a radian is made, okay? Now, we're more comfortable with degrees. I hope that by the end of this chapter, you are going to be more comfortable with measuring radians. Okay, that will be my goal, is that radians become more comfortable to you. Okay. All right, so let's talk about converting radians to degrees. Something that you've done, but let's talk about what the logic is behind that. All right. So we just defined that a measure in radians is the arc length over the radius, right? So here I have a circle with radius r, okay? And what I want is for our angle to be the entire circle, okay? Well, we know how many degrees that is, right? How many degrees is an entire circle? 360. Okay, well, let's talk about the radians. If our radian measure is the arc length over the radius, okay, well, our radius is r. The arc length for the entire circle, we also could call that what? It's circumference. And how do you find circumference? 2 pi r. So if the arc length of our angle is the entire circumference 2 pi r, then our radian measure is 2 pi. All right? So what I want to demonstrate to you is that 360 degrees is the same as 2 pi radians. Okay? Something that you knew from probably last year, maybe even geometry, I don't know, probably last year. Okay? So we're going to use this fact to help us convert. Now, if 360 degrees is the same as 2 pi, then that means 180 degrees is the same as what? pi. And that's the fact that's what we're going to use. Okay? Okay, so first, converting from degrees to radians. I have an angle measure of 120 degrees. I want to know what it is in radians. Okay, in science class, you work with unit conversion, right? Okay, when we multiply that by a fraction where numerator and denominator are the same length. Do you agree? Okay, so if we want to convert this to radians, we have to multiply by 1, essentially, but we want to cancel out the degrees, right? So we need our degrees to go in the denominator so that the degrees cancel. Well, 180 degrees is the same thing as pi radians. Okay? So essentially, we have 120 over 180 times pi. Reduce that fraction down to 2 pi over 3. Okay, let's talk about going the other way. I have an angle measure of 7 pi over 9, but I want it to be in degrees. This is in radians. Okay, let's talk about how we know it's in radians versus degrees. Degrees, we write a little circle in that subscript, right? We write that, or superscript, excuse me. We write the degree symbol. If there is no degree symbol, we assume radians, which I will do on your quiz. So if it's an angle measure in degrees, you better have that degree sign. Okay? All right, so we have a radian measure. We want it to be in degrees. We need to multiply by something where we end up with degrees in the numerator. We know that 180 degrees is the same as pi radians. Conveniently, our pi's do cancel. We have 7 times 180 divided by 9, which ends up being, what? 140? 140 degrees. Okay. Something that you did last year, here's your reminder. Okay, you'll have, I don't know, like 3 or 4 of these in your homework to practice this evening. All right, let's talk about graphing angles in standard position. Okay, we can have angles of any measure. We can have measures 10 degrees, 400 degrees, 5,020 degrees. Okay, basically we have to just keep rotating. All right, if we are in standard position, where would our angle begin? Okay, on the positive side of our x-axis, this is always going to be where your initial side is. Okay, which way are we going to rotate? Okay, and then we rotate counterclockwise. We rotate counterclockwise with our terminal side until we get to the measure that we want. Okay, so let's remind ourselves that we have 4 quadrants, right? Quadrant 1, 2, 3, and 4. If we are measuring in degrees, if we do not move at all, that would be 0 degrees, right? But as we rotate counterclockwise, what would this measure right here be? 90. What would this measure here be? What would this measure here be? 270. and then we could rotate all the way back to 360. So an angle of 0 and an angle of 360 degrees, they're going to have the same terminal side. They're going to stop at the same place. Okay? We can have measures above 360. That just means we keep rotating and rotating and rotating. Okay? If we have a negative angle, which way would we rotate? We would rotate clockwise. Okay? In the same fashion. Now, let's just get a little bit more comfortable with our radian measures. Okay? If we begin with our initial side right here and we rotate counterclockwise, 90 degrees would be the same as what radian measure? Pi over 2. If 180 degrees is the same as pi, half of that, 90 degrees, is the same as pi over 2. That's going to be something that you're going to need to know automatically. Okay? So pi over 2, pi, 270 would be the same as what? 3 pi over 2. Okay, if 90 degrees is pi over 2, then 270 is 3 of them, right? And then we would rotate all the way back to 2 pi. Okay. All right. So what does this look like if we're actually going to graph these angles? Okay, we're going to graph the angle of 120 degrees and negative 750 degrees. We need to think about which quadrant our angle is going to land in, okay? So first thing we should probably think about is if it's more or less than 360. 120 is less than 360, so we're not going to go more than once around, right? Okay? 120, which quadrant do you think that's going to land in? Quadrant 2 is less than 180. Is it going to be closer to 180 or closer to 90? Be closer to 90, right? It's 30 away from 90, 60 away from... So it would be about there. Okay? When I rotate, I like to put a little arrow with that rotation so I can see which way we rotated. Okay, so that is 120 degrees. Now, 750. First of all, we are rotating in the negative direction. Do you agree? Okay, so we're going to have to rotate clockwise at least once. If I rotate once, how many more negative degrees do we have left to go? Hmm? 390. So we're going to have to go around twice. Going around twice is how many degrees? 720. And so we would just need 30 more degrees. So you see how you can tell that I went around twice plus a little bit more, and then I put that little arrow so we could see which way we rotated. Caleb, you okay with that? Okay, let's take your routine. What we really have to get used to is graphing radians. Okay? The only way you're going to get comfortable with this is to what? Practice. If you don't practice, you're not going to get comfortable with it. Okay? So, 5 pi over 2. Is that bigger than 2 pi? It is. If it helps, we can think about the fraction without the pi. Okay, is 5 halves bigger than 2? Yes. And 5 pi over 2 is bigger than 2 pi. Okay? We've gone around 2 pi. How much left do we have to go? How many more radians are left? A half of pi, right? And we know that a half of pi is the same as 90 degrees. So this would be our 5 pi over 2 angle. We rotate 2 pi and then pi over 2 more. Okay. Last but not least, we are going to graph 4 pi over 3. Yes.
If you select, since it's pi over 2, wouldn't you go around twice?
Well, once all the way around is 2 pi. Are you with me? You were thinking pi. Yeah, pi is the same as 180 degrees. Okay? All right, so 4 pi over 3. Less than 2 pi, yes or no? Less than 2 pi. Because 4/3 is less than 2. Is it bigger than 1 pi? It is bigger than 1 pi, which means it's going to be more than 180 degrees. However, 4/3 is less than 3/2. Right? Okay. So it's going to be here in the 3rd quadrant. Okay. Eventually, you will know automatically that 4 pi over the 3, what degree measurement that is. Okay. All of the pi over 3, pi over 6, pi over 4 measurements, you are going to know automatically, and we're going to work on that next week. Okay. All right, it's getting a little quiet in here. I would like to give you some time in your pod to talk about these 4 vocabulary words. We're going to talk about each of these 4. I don't care if you define them or draw a picture of some kind, but I want you to at least discuss or draw these 4 terms. Okay? I'll give you about a minute or so to talk about these 4 terms. Ready, set, go. A section goes in a circle of that.
Oh, yeah, it's like yeah.
It got really quiet in here. When we're done discussing. Raise your hand if you need more time. Okay, how many of you drew pictures? Okay, just your choice. All right, so let's talk about the first 2. Complementary versus supplementary. Cod 5, what does it mean to be complementary? Okay. 2 angles have a sum of 90 degrees. Now we're also talking about radian measurement, so we could also change this definition to 2 angles whose sum is pi over 2. Okay. All right. Supplementary. Cod 4.
Angles to like 180.
2 angles whose sum is 180 degrees. Let's also talk about it in radian measurement. What would that be, Marissa?
Or pi.
Pi. Okay. I'm going to ask you to find supplements and complements of both radian measurements and degree measurements. Now, how many of us feel pretty darn comfortable finding complements and supplements of degree measures? Okay, like if I said 30 degrees, could you give me the complement and supplement fairly quickly? Yeah. If I gave you 12 degrees, could you give it to me pretty quickly?
So is it okay if you just like find a complement in degrees and convert it to radians?
You can do as much work as you want to. I am just going to tell you that there could be some inefficiency to doing that. If I give you 5 pi over 12, this is the example we're going to do if you want to write it down. Caleb, what you're saying is you would convert this to degrees, find the two measurements, and then convert it back. Okay? Technically, you're still going to get the right answer, but how much more work are you doing than everyone else? You're doing a lot more work. Okay? So let's talk about how to do it with radian measurements. Okay? So let's find the complement. Complement means these two angles would add up to be what measure? Pi over 2. So how would we find the complement using that information? What would we set up? Caleb?
If you do pi over 2 minus the 5 pi over 12.
Yes. Okay. Now some of you are thinking, fractions. Not a big deal. You all know how to work with fractions, okay? We just need a common denominator. It's fairly easy to do. Okay, we need a common denominator of 12, which means we just have to multiply this by 6 over 6. So we have 6 pi over 12 minus 5 pi over 12. Our complement is pi over 12. Some of you don't even have to write that work out. Some of you can do that in your head, and I'm fine with that. Supplement, okay, means two angles are going to add up to pi. So to set that up, we're going to go through the same process, right? What is pi minus this angle? Okay. All right. Common denominators, we have 12 pi over 12 minus 5 pi over 12. So our supplement would be 7 pi over 12. All right. I do not feel like we need to practice that in class in degrees. Okay. All right. So let's move to our next word. This is probably the more difficult one to remember out of the 4. Coterminal angles. Part 2. What did you come up with for coterminal? Okay, they end in the same spot. Okay, let's break down the word coterminal. Co means what? Co-captain. Okay, together, like sharing, right? You share that, like if you're co-captains, you share the captain job, right? Terminal. We have terminal sides of angles, right? So we have angles that share the same terminal side. So as Pod 2 described it, they end in the same spot. Nick even said they're 360 degrees apart, okay? Doesn't necessarily have to be 360 degrees. They can be 720 degrees apart. You could be really obnoxious and say 360 degrees times 5, whatever that is, apart, okay? But as long as they end in the same spot, we are talking about a coterminal angle, okay? So we're going to find some coterminal angles for 70 degrees. technically, how many coterminal angles would there be? An infinite number. Not going to make you find that many. All right? That would be impossible. But we'll find 2 or 3. Okay? So first of all, which quadrant would 70 degrees lie in? Okay? That one's kind of nice, right? It's less than 90 degrees. We know it's going to... That's our 70 degrees. Okay? Well, let's talk about the easiest one. All right? If we keep rotating in the positive direction, right, we can rotate 360 degrees more, right? So if we add 360 degrees to that, what's our angle measurement? What'd you say? 4. Okay, and we could do that again, right? We could rotate another 360 degrees in the positive direction, and we could be pretty obnoxious with that, right? Let's do that. If we rotate twice around, so if we add another 360, we'd be at 790 degrees. So those are all coterminal angles of 70 degrees. Now, I am going to make you find negative angles, okay? So, we could take 70 degrees, and if we want to go the other way, what would we have to do? Subtract 360 to get negative 290. Okay? Our other angle is 3 pi over 4. Three pi over 4 is in the second quadrant. We're going to do the exact same thing. We're just going to do it with radians. So our angle is 3 pi over 4. If we want a coterminal angle, we could rotate in the positive direction. If we add 2 pi to 3 pi over 4, we would get 11 pi over 4. That's a coterminal angle. We could do it again and add it again. Or we could take 3 pi over 4 and we could go the negative direction. We could subtract 2 pi to make it to negative 5 pi over 4. Okay. I believe your book will ask you for a positive and a negative measurement. All right. Sometimes you can simply add 360 and subtract 360. However, if you have an angle measurement of like 400, is subtracting 360 going to get you a negative coterminal angle? No. So you would have to do it again. Okay. All right, your last word, an angle sector. Who can describe to me what an angle sector is? What's a sector? In a circle, what does a sector look like? Thanks, Trivial Pursuit. What does it look like? Looks like a piece of pie. Okay? This is a sector. Okay? So we're going to have to kind of zoom through this here. Arc length is the distance between 2 points on the circumference of a circle. Okay? We've already kind of talked about arc length, but basically we rearranged that radian formula. Arc length equals theta times r. That is how you find that measurement if you know theta and r. Okay. So we're talking about the arc length, the distance along the circumference of that sector. Okay. It is so important that theta is in radians. If theta is not in radians, this formula will not work. Okay. There'll be some words on the next page. I'm going to tell you which ones to write down. Okay. I want you to write down that we have an angle. We have a central angle of 30 degrees in a circle with a diameter of 3.6 inches. Okay, we're going to find the arc length. We need theta and r. Technically we have theta, but is it in the correct measurement? No, it cannot be in degrees. So this is where we would have to use our skills of converting, right? We have a measure of 30 degrees. What do we multiply that? To get it to radians? Pi over 180. We want the degrees to cancel, so 180 has to go downstairs. So our radiant measure is pi over 6. The radius 3.6? No, our diameter is 3.6, which means our radius is 1.8. Okay? I'll save you some time of having to get your calculators out. If you take pi divided by 6 and multiply that number by 1.8, you would get 0.942. Now, we are talking about the arc length. Okay, a piece of circumference. That is a linear measurement. So whatever the label was for our diameter or radius would be the label we have for our arc length. All right, our last formula. Going back to what a sector is, if we want to find the area of a sector, okay, we know how to find the area of a circle, but if we want just the area of that piece of pie, then this is the formula that you would want, okay, that yellow area right there. Once again, theta has to be in radians. Okay, we're not going to do the example for this. This is a formula that you worked with last year, okay? And so the bell's going to ring here in about a minute and a half. On your gold sheet, you have your assignment. Just a reminder, because it's been a few weeks, the ones in bold are required. The non-bolded problems are ones that I still think you should do, but that is up to you whether you need to do them or not. I will come around and check homework tomorrow as you're doing a warm-up problem, and we'll keep up this different sheet. Okay. Does anybody have questions about their schedule? Changes, anything that's missing? There's a schedule this morning that a teacher had that was like missing a class period. So look at your schedule, make sure it all looks okay. How many of you have the exact same schedule as last year? Or last semester? That's it? Really? Wow. Okay.